Hi guys, welcome to Code Bashers. Guys, in this video, I will be discussing coding question which were asked in the TCS NQT exam of 2023 batch students. So guys, many of you are requesting me that I should upload video daily and for all the questions. So guys, I'm trying to upload video daily for different questions, but making the video for all the questions is not possible for me. Plus, I don't have all the questions with me. So if you find any of the questions that you wish to for me to provide solution or make a video, kindly contact me on Telegram group and share your questions there. I will be happy to help you there. Okay. And guys, this is not the first video that I'm uploading. So if you're new to this channel, please see that I've already made two videos, and both of them were uploaded yesterday, wherein I have discussed the actual coding questions of TCS NQT for 2023 batch. I will give you the link of this playlist in the I button or in the description box. Make sure to visit it. And guys, if you have not subscribed to the channel till now, please subscribe it and please share this video among your friends also, so that they can also subscribe and they can also see that what type of questions are getting asked. So guys, now let's start this video, and before starting the video, please hit the like button as well as the subscribe button for this channel. Okay, so guys, the pattern of this video is same, that first I'll be discussing the question, then I'll be discussing the approach of that question, and then in the later part of the video I will be discussing the code of this particular question. And guys, do hit the subscribe button if you have not subscribed till now. Okay, so let's just move towards the question. Here the question here is, Bob is going to bet today on horse riding. Okay, there are n horses listed in a sequence of 1 to n. The probability of winning of each horse is different, so the prices for making a bet on the horses are not the same. Okay, there is no limit on the number of horses on which he can bet. So it is possible that he can bet one horse, it is possible that he can bet two horses, or it is possible that he can bet all the n horses. Okay, so now but he thinks that if he bets on the continuous sequence of horses, then he has a better chance of winning. So let's just see what does continuous sequence means afterwards. Okay, now at present just read the question. Okay, so now Bob will get k units of money if any horse on which he bets will win. Okay, but as the award is only k units, so he wants to put money less than k, so that he does not end up losing. Okay, next is Bob wants to bet as many horses as he can. So what does till now what we have understood, like there are horses, and price for every horse betting is for every horse is different. Like here it is x, here it is y, so z, here it is. Okay, so price of bet on every horse is different. Now what does how much money does Bob have? So Bob have k units of money. So here you can say k units, or you can say k rupees Bob has. Okay, now he wants to bet on the horses, but he's saying that he thinks that if he bets on the continuous sequences of horses, then he has a better chance of win. What is a continuous sequence means? Let's just suppose there are horses 1 2 3 4 5 and 6. So these are the horses. So now if he is betting in the continuous sequences, then he has a better chance. But this continuous sequence, this is a continuous sequence, like 2 3 4, these are continuous sequence. 3 4 is also a continuous sequence. 3 4 4 5 6, like this. That is, you can say a sub array. If he bets on the horses in a sub array, then he has a better chance of winning. So now we know, now for the price of every horse is different. Betting on every horse is different. Let's just suppose there is horses 1 2 3 4 5 6. Now the price here is 10 rupees, here it is 5 rupees, here it is 6 rupees, here it is 8, here it is 9, here it is, let's just suppose 7 rupees is here for betting, okay, on this horse. Now he says that if he bets on the continuous horses like this, then he has a better chance of winning, and he wants that he only have k units of money, and he will only put less than k amount. That is, he will only let's just suppose if he has 100 rupees, if k value is 100, so the betting amount, the total amount that he wants to bet will be always less than 100. So betting amount is always less than k, that is always less than 100. But he wants that he should bet on the continuous sequence of horses. So as many horses, we have to find that how many horses he can bet on, that is maximum number of horses he can bet on, uh, given the condition that he can bet only in continuous manner, plus he can only spend less than k amount. So we have to find that how many horses, maximum horses he can bet on, which are in continuous order, plus they have the total betting price less than k. So I hope now the question is clear to you. So here the last line also say, Please help Bob to find out the length of the maximum continuous sequence of horses on which Bob can place bet. And remember, he will invest money less than K only. So he will bet on the continuous sequence of horses, and the total amount that he will be betting will be less than K. K will be given to us in the question. Now, next point is, if there are more than one possible combination, Bob will bet randomly on any of the chances, any of them. So let's just suppose first bet that he's making is this 5, 6, 8. Okay, these are continuous horses. So total money is again less than K. Let's just suppose K value is 20. Let's just suppose K value is 20. So you can see that your total amount is less than 20. Now next thing, the next bet is next he can bet is 9, 7 here. So here total amount is 16. Here it was 14 plus 5. It was 19. So here three horses he can bet. Here on two horses he can bet. So since we have to find the maximum number of horses, so answer will be 3 here. Okay. And if there were two possibilities that two orders, two combinations are present, like this 5, 6, 8 is also present, and 8, 9, 7 is also present, so he can randomly bet on any of these combination to win. Okay, so again we just have to keep these two in mind, that is we have to find that the maximum number of horses he can bet which are in continuous order, and total bet amount is less than K value. So now just let's just understand with the help of the example that what the question is actually trying to say. So here you can see the number of horses are 10. These are number of horses. Okay, the K value is 100. That is the amount of money that Bob can spend, but it should be less than K. That is, it should be less than K. That is less than 100. Okay. Now these are the betting prices. These are the betting prices of different horses here. So now, you have to tell that what are the maximum number of horses that are in continuous order plus the bet amount. Total bet amount is less than the K value. Okay. So here you can see, just a second, let me just do it. Okay, so here you can see that there are some combinations that are present, that is 5, 20 and 20. So here the total value will be 90. The number of horses that are bet are 3. Here also you can see the total value is 30 on the betting price, and they are in continuous order, and the number of horses are 3. Okay, and if you see this input very carefully, then you can find that no more combination occur which have length greater than 3, greater than 3. So here the answer will be 3. So two combinations are present of the same length, so he can bet on any of these combination, and we will just have to return the maximum number of horses he can bet on. So here it is, the answer is 3 here. Okay, so I hope this thing is clear to you. You can see the total betting amount is less than the K value. The total betting amount is less than K value. Let's just understand the example, next example, and then we will see the approach. Okay, so next example again here is 10, 100, and these are the betting amounts of every horse. So here the output is 1. How it is 1? So if you will see that the total value of the betting horses should be less than the K value. So if you see in this particular example, there is only single values that are present. Here you will say that we can take 20 and we can take 60. So total amount will be 80. But in the question it is mentioned that they must be in continuous order. So if to include 20 and 60, you must also include 90 also. So here this particular combination will be not possible. And if you see the continuous combination, then no such combination of two or more horses are present. So here the single combination you can take. One is there, one combination is this, second combination is this, third combination is this, fourth is this, fifth is this, sixth is this, seventh is this, and eighth is this. And also these are also combination. Okay, so these are also combination 9. So every combination is a single horse. So here the output will be 1. Since all these combinations are giving me the same result, same number of horses, so I can bet on randomly on any of the horse, but the answer will remain that I can only bet one horse only. So I hope now the question as well as the example is clear to you. Now let's just see the approach of this particular question. Okay, so guys, now let's just see the approach of this question. Now what we'll do, see, we will be using a sliding window approach in this particular question, wherein our sliding window will be denoted by I and J values. That is, the elements inside this I and J will be the elements in the current sliding window. Okay. Now sum here represents the sum of the bets that we have placed inside that sliding window. So if our I value is here and J value is somewhere here, so this sum will represent the sum of the bets inside the sliding window. Okay. Now count will store that how many horses are present in the current sliding window. Okay, how many horses will be present in the current sliding window. And F count, that is our final count, this variable will store that what is the maximum count that we have reached when our J value, when we will traverse this entire array, when we'll traverse this entire array and our j value will move at the end, then the value in the f count will denote that inside this particular array, where what was the size of the sliding window that met are all the conditions, that is the amount of money spent should be less than k, and there should be maximum continuous horses on which we can place bet. So here it will f count will show us that when our array will be traversed fully, this value this f count will store the value of the final answer here. Okay, so let's just see how we will be moving ahead with this approach. Just a second. Okay, here it will be j value. Now say we are in the starting, we have I equal to 0, index j equal to 0, index sum equal to 0, count equal to 0, f count equal to 0. Now we will always add in the sum with the help of the j variable, and we will always decrease in the sum with the help of the I variable. So you will get more clarity once we move ahead. Okay, so what will happen? Now see, what is the j value? It is 30. What is the current sum value? It is 0. So what we'll do, we will check if we add the j value into our sum value. If we add our j value with our sum value, is it crossing our k value? So here sum value has become 30. So is 30 greater than k? Is 30 greater than k? No, it is not overshooting. So yes, we can place our bet on this particular horse. So our sum value will become 30, and our count value, so once we will be able to place our bet on this horse, what we'll do, we will simply increment our j variable. Now our j value has been incremented, and we have successfully placed our bet on this 30th horse. So therefore our count value has become 1 here. And at every step we will be checking comparing the f count with our count. So f count will store the maximum value of f count and count. So here the value of f count is 0 and the count is 1. So what is the maximum value in f count that will be coming? It will be 1. So here count is 1, here count is 1, f count is 1, count is 1. Okay, now we have moved to this jth location. Now again we will check whether adding the value, whether placing the bet on this particular horse, can we do that? So we will do 30 plus 40. We will check here. So 30 plus 40 is 70 here. So is 70 overshooting our k value? Is 70 overshooting our k value? The answer is no. That is, this 70 is less than k only. So it is a valid bet, because till now we have placed our bet on this 30, and now we can place our bet on 40, because total value will be 70, and these two horses are, you can say, continuous only. So this 70 is less than 100. So this horse, we can again place our bet on this horse. This is a valid horse. So once this is a valid horse, then what we'll do, we'll simply do j plus plus, j will move to the next location. We will do count equal to 2, that is on 2 horses that are meeting our condition. By meeting our condition, we are successfully able to place bets on the 2 horses. Now again we will compare f count with count. Since f count will contain the maximum value of f count and count, so f count value will update it to 2 here. Okay, now we have moved towards the j. Now again we will check. Now our sum value is 70. Okay, now we will again check. Just a second. Now we will again check, is the current horse we can place bet on. So 70 plus 50 here, it gives us 120. So can we afford this? So answer is no, because 120 will overshoot our k value, and our sum value should always remain less than k. So this means that this placing the bet on the j is not a valid answer. It will not be a valid move. So for considering j, what we have to do? We will have to squeeze our window. So here window size till now has been represented by I and j. So I and j, this will be our window size. Okay. So since now our value of sum has overshooted the k value, what we'll do, we'll start to decrease the size of the sliding window. So now what we will do, we will first of all subtract the value of this ith variable. From the sum, that is 120 minus 30. It will be equal to, what was our current sum? See, we were just checking here. Just a second. By doing 70 plus 50, we were just checking that whether it will shoot our value or not. Our sum value till now is 70 only. So now you can see that 70 plus 50 will overshoot our k value. So at this point, what we'll do, we will squeeze our sliding window, and by squeezing our sliding window, we will subtract this 30 value from the sum value. What was the actual sum value? It was 70. So 70 minus 30 70 minus 30, we all know it is 40 only. Okay, and we will do I plus plus here. We will do I plus plus here. Now again we will check whether on the sum value when we are trying to add the j value, that is 50, is it is it a valid move? And while, oh, okay, one thing I forgot, see, while we are moving from I here to I here, while we are doing this, what we'll do, our size of the window has decreased, so our count value, current count value will also decrease. It will become 1. Okay, now our I value has come here and our count value has become 1. Now f count will again compare, f count will be 2 and count will be 1, so therefore f count will represent 2 only. Now our I value has become here. Now what we have done, now we will compare our j value, that is 40 plus 50, it is 90. So 90 is a valid move. So 90 is a valid move. So again, since it is a valid move, we will again move our j value to the next pointer and we will update our count value to 2, because this count value of 2 represents these two elements, that is 40 and 50. These two elements have been represented by this count value. Now again f count and count are same, so f count will not update itself. Now again we will check the current sum value was 90. Now we will check, now we will add j value, that is 20. 90 plus 20, is it a valid move? We are just checking, is it a valid move? Our current sum is still 90, but 90 plus 20, is it a valid move? So answer is no, it is not a valid move. So what we'll do, again we'll try to squeeze the window size. How we'll squeeze it? We'll subtract the I value from the sum value. What was our sum value? It was 90. Sum value was 90. We will subtract 40 from it. It will become 50 here. And once we have subtracted it, we will move I plus plus. We will move our I here and I here. Once I has moved here, now the count value will be decreased by 1. That is 2 will now become 1. Count minus minus. It will now become 1. Now again we will check whether this 50 plus 20 we can add. So answer is 70. So answer is 70. Yes, this is a valid move. So this value can be taken into account. Now j value will move to now j value will move ahead. So this 20 we have considered and this 50 also we have considered. So this count value has become 2 here. Okay. Now our current sum value is 70. Now our current sum value is 70. Now we will check the 70 plus j, that is 70 plus 20. Is it a valid move? So yes, it is a valid move. So it will become 90 here. Count value, j value will move here. J value will move here. Count value will become 3. And you can see count value is greater than f count. So our f count will also get updated to 3 only. So it will become 3 only. So our total sum has now become 50 plus 20 plus 20. Count value is 3. So these three elements have been considered. Now our current sum value is 90. Now our current sum value is 90. Now we will check 90 plus 10. 90 plus 10 is equivalent to 100. But we can only spend the money that is less than 100. So 90 plus 10 is 100. So this is not a valid move for us. So when it is not a valid move for us, what we do? We will squeeze this sliding window and we will subtract the ith value from the sum value. So sum value was 90. 90 minus 50, that is 40 here. 90 minus 40, that is 90 minus 50, that is 40 here. We will do our I plus plus. We will do our I plus plus. I value will move here. And now our count value will decrease because we have done I plus plus. It will become 2 here. Okay. Now see. Now again we will check on this 40. Can we add this jth value? 40 plus 10 equal to 50. So yes, we can do it. So what we'll do, since it is a valid move, we can move j ahead. We can move again count to value of 3. Again count and f count are same, so f count will not update. F count will remain 3 only. So this step will be continued till this j value reaches to the end of the array. So after this j values reach to the end of the array, this f count variable will know that where all the conditions have been fulfilled and how many horses we can bet on. So here you can see answer is 3 here. Okay. So I hope now the approach is clear to you. If it is not clear to you, then again rewind the video and see, it will be definitely clear to you. So if you have not subscribed to the channel till now, please subscribe it. And now let's just move to the coding part of this particular question. Okay, so guys, let's just see now the how we have to write the code. For saving time, I've written the code because this video has become too long and main part of this video was approach only. Code you will be able to write on your own. So what we are doing, we are first taking the n as input, that is number of horses. Then we are taking the k as input, that is the maximum amount of money we can spend. Next we are taking all the bet amounts of the different horses till n value. Okay. So now we have taken 5 variables. As I have told you, I variable, j variable, sum, count and f count. I've told you in the approach section for what all these variables are useful. Now let's just see what we are doing. I have told you that, see, while our j value is less than n, so we will have to iterate over the array till where we will have to iterate the array. While our j value reaches outside the array, that is j is less than n. So till then we have used the for loop. Now this if condition I have not told you in the approach, but I will come back to it on later part. Let's just first see else if conditions and else condition. Now see, earlier our sum was 0. Earlier our sum was 0. At every point we were checking whether the sum value plus ARR of j value, whether our sum value plus ARR of j value, whether our sum value or ARR of j value is greater than k, is greater than or equal to k, whether it is overshooting the k value or not. So if the answer is yes, that yes they are overshooting the value, then what we were doing, we were shrinking our window. We were shrinking our sliding window. What we are doing, we are simply subtracting ARR of I, the ith value from the sum value. Then we were doing I plus plus, and we were doing count minus minus. I have told in the approach that why we have done this, to shrink the sliding window. So if the sum plus ARR of j value were greater than k, so then we are approaching this step. Okay, now else condition, that is when our sum value plus ARR of j value is equivalent to is less than k, okay, then what we are doing, that is the else condition. Then what we are doing, we are simply increasing the size of the sliding window. We are simply doing sum plus equivalent to ARR of j plus plus we are doing, then we are doing count plus plus. And after this loop is over, after this while loop is over, or at every iteration what we were doing, we were always comparing the value of f count with the count variable. We are always comparing. So and the max value of f count and count will always get updated into the f count variable. Okay, and at the end of the loop what we are doing, we are again doing the same thing. That is we are updating the f count value. Okay, we are updating the f count value, and in the end what we are doing, we are simply see out f count, that is the how many number of horses we can place bet which are continuous in nature, and the total sum of total bet sum is less than k value. Okay, so this was the entire approach that I have told you. Now there is one if condition that I have not told you in the approach, that is what if a particular element, what if a single element only is greater than or equal to k. That is, let's just see the case where okay, let me just copy, just a second, let me just copy these values. Okay, now let's just see a case where a single element okay, let's just suppose our k value is 35. Let's just suppose our k value is 35, and these are elements 30, 40 and 30, 40 and 30. Now when our I value was here and j value was here, then this is easily, we can use this particular scenario. That is, we can easily place bet on this 30 value, because the entire sum for this single value was less than 35, and some value is also become 35. Now let's just suppose we have our I value and j value at 40. Now see, 40 in itself is greater than k. We were always talking about the sum value to be greater than k, but here a single element is greater than k. So here what we have to do, we simply have to ignore this element. If we have, if anywhere in the array we have a particular element that is greater than k, what we will do, we'll simply ignore that element, and we will we will start our entire process from the next element. That is, if we have encountered this 40 here, we know that 40 value is greater than k, so it is of no use. What we will do, we will start our entire operation again from the next value, that is from this value, next value after the large value. That is, from this value we will start the entire operation again on this particular array. So once we have encountered an current element is greater than k value, what we'll do, we'll simply do j plus plus, that is moving our j pointer to the next element, simply ignoring the current element, and we'll do I equivalent to j. Initially you know that I and j were equal, or I and j were 0, so it means I and equal to j initially also. So once we have encountered a large element, that is the size is greater than k, then we'll simply do our entire operation again. From the next element. So we are simply ignoring that element by doing j plus plus, and we are simply placing the I value with the j value only, because initially also I and j were equal, and after this encounter also I and j were equal, and again we will be starting we are doing count equivalent to 0. we are doing count equivalent to 0. Okay, so here again you can initialize all the variables again, that is sum equivalent to 0, and f count again you can say no, not f count, because f count will always maintain the large value. So here again these operations will be done again. All the operations will be started from next element again, that is j plus plus by ignore, because we are ignoring the element I, we are making I equal to j, which was initially also I and j were equal, and count again we are starting from 0 only, and sum also we are starting from 0 only. So this code again, let's just see on the inputs whether this is passing the test cases or not. So let's just first say, let's just run on this particular input, that is 10 90 80 20 90. This was example 2 of this question. So here the answer will be 1, because only a single element is present which is less than k. There is no two elements which are continuous, and we can sum them so that their value become less than k. So here the answer will be coming out to be 1. And if we talk about the first input that we have taken, it was this only. Let me just copy it. So I think it will give us the correct answer. That was 3, where it is. Okay, so let me just copy from here. And guys, if you have not subscribed to the channel, please subscribe it, because it gives me immense, you can say, motivation to make more such videos. Please hit the like button if you have not hit the like button till now, and please share it with your friends as soon as possible. Okay, let me just run this particular input. It will show you that our answer expected output is, what is our expected output is 3. Okay, so let me just run it. Okay, so here you can see that output is coming as 3. So now let's just see what is our in a case where a single element is greater than a k value. Okay, so let me just say that we are inputting only three input values. K value is 100. First value is, let's just say, 12. Next value is 110, and next value is 11. Let's just say it is 30 and 40. Okay, so it will give us 4. It will give us 2 as our answer. The expected answer is 2. Let's just see what it will give us. It will give us 2 only. Okay, so you can see here 2 is giving us, because see at 1110 what has happened, this 1110 value is greater than 100. So our entire operation will start from the next element, that is from the operations that we were starting from initial of the array. Now we will start all the operations from the next element, from this large element. So these two variables are, we can take, these two horses we can bet on. Okay, so guys, this was the code, and this will pass all the test cases that will be given to you. And if you like the video, please hit the like button, and please comment down that yes, you want more such videos. I will be happy to make.